Hey guys, I hope you're well. The last couple weeks I've been slipping again. I tend to do that. I slip away from my hobbies, like my ham radio hobby. Look at the desk. Oh, hi Scout. Hi Scout. Look at my desk. After my 100 milliwatt fun I had for a few weeks, I haven't done anything else with it since. Once I started working on my radio restoration, my HW-16 restoration, one thing I want to try to do today is build the 1 watt attenuator. I disconnected the 100 milliwatt one. I can have a lot more fun using 1 watt QRP. It's easier to sign /1W than to sign /100MW. So I'm going to try to get that attenuator done today. But for today, I want to do a catch-up, a recap, if you will, a recap of my recap job. I want to do a recap of where I stand to date with this HW-16 because it's time to do the troubleshooting and get it working. All the parts that have been replaced that I plan to, unless I find a couple surprises. But let me show you. This is the video I'm making today. We're going to start with where we're at today, and this is the list. I'm going to point each of these items out real briefly on the radio. Okay? Hang on. Hang on. See this tune control center of your screen? That was very hard to turn. When I first got this radio, it was very hard to turn. The knob's is not in the right position, I see. But you could barely turn it. And I knew from my experience with these Heathkits that tune control connected to a variable capacitor, which it does. You see that shaft coupler? Hang on, I need to put you on a tripod. One moment. Okay. This rubber coupler was rock hard. Scout is under my desk right now here asking for some loving. Might have to pause you and give Scout some loving. Hi, Scout. This was rock hard, which would be okay, I guess, if the shaft and this capacitor shaft were in alignment, but they were not. This capacitor here was mounted at an angle so that when you turn this shaft, you were forcing this rock hard rubber coupler to flex, and it wouldn't. That control was hard to turn, man. So I went out in the garage, I found a piece of fuel line tubing is what that is. I loosened the 4 mounting screws on this capacitor. I'm going to try to talk without whistling my S's. I loosened the 4 screws and I arranged it in a straight, you know what I'm saying? I made it straight, man. And now, it turns buttery smooth. Hang on. Okay, boy, that was way too wordy and too long. We'll do better. I serviced the band switch. I'm not going to talk about what I did to it in this video. That will be the subject of another video when I do my Heathkit Hints series. I'm going to do a tutorial on servicing this band switch. But I serviced the band switch. I cleaned this detent. This is a detent component. I cleaned the detent. I re-lubricated the detent. I lubricated the panel bushing. And works great. I cleaned the dial, the friction drive. Heathkit loves to use these friction drives in their cheaper equipment. And actually, in a lot of their equipment, in the whole SB series for their calibration tuning dial, it used a. Anyway, let me flip this over and show you the bottom. So that's the bottom part of the dial. I'm going to zoom you in on this part here. One moment. So there you go. For lack of a better description, this plastic round dial is sandwiched between two washers for the most part, and they're pressed together by the spring, and it works great. Works a treat. And yeah, this was dirty. It's not the dirt you got to worry about. It had some kind of oily substance on it. I just took a Q-tip and some alcohol, cleaned up that portion of the dial. You don't have to do the whole dial. Just the part where it engages the friction drive doodad. Okay? Hang on. I restuffed those 3 electrolytic capacitors. Aren't they pretty? You can't even tell. And I replaced these 2 electrolytic capacitors, 22 microfarads at 450 volts. They form the negative bias supply, the negative 150 volt bias supply. I replaced them. This is the way we look at shit. Look at shit. Look at shit. I had to replace this resistor. It was the only one that was open in this radio. I thought there were others. I was wrong. This is open. It was open. It's 100 ohms, 7 watts. I replaced it. This is the way I show you shit. Show you shit. Show you this volume control pot. I cleaned it, and it seems to be working okay. I hope so. That would one, excuse me, I'm sorry. That one would be easily replaced, meaning easy to find one. Hang on. Oh my God, I hit the stop. I hit the lock button on my phone. I hope that last segment recorded. I cleaned these 2 pots. One's an RF gain control. The other is a power level control. I changed them. What am I saying? I changed them. I cleaned them. They seem to work fine. And after calmer heads prevailed, I didn't change every resistor that was out of tolerance. They're all 10% resistors. If it was 11% off, I didn't change it, but I did change 7 of them. I repaired 1 million poorly routed wires underneath the chassis. I've complained about it before. There was much crying and gnashing of teeth. The builder did a horrible job of routing the wires, and he refused to clip off any excess leads. But that's all done. I did that. And lastly, I replaced V6, the audio output tube. That is an audio preamp on one section, an audio power amp on the other section. Had to replace it. And that'll be the subject of another video. Right. Troubleshooting an audio output tube that runs excessively hot. In this case, smoking hot. I'm going to talk about the troubleshooting I did. It'll be a lesson in vacuum tube operation for a lot of you. Okay? Hang on. Okay. The next item is the AC safety mod. One of you fellows asked that I show you what I did to this radio or what I plan to do with it to make it safe, to make it so it won't kill you. I'm going to talk about that, okay? I've got to stop this now and see if my one segment got recorded. If not, I'm going to cry. Bye, guys. Boy, my video has grown long. I'm not going to be able to include everything I wanted to. A couple items I'm going to do in a separate video. One of them being troubleshooting V6, the audio output tube. Might be interesting for a few of you that really don't know how a vacuum tube operates, or how you might troubleshoot one. But right now I'm going to talk about the AC safety mod. You notice that I installed a 3-wire grounded power plug. I'm going to zoom you in. One moment. You'll see this on the schematic when I show you the schematic, but you see right here the power cord comes in. Okay. Boy, I can't see what I'm pointing at. The black, the hot lead. Where am I? You know what? I've got to pause you. I can't see a thing. Boy, this is very, very poor. The hot lead is right here. It comes up, goes to this terminal strip lug, which also connects to the fuse. The other leg of the fuse hooks to the terminal strip lug over here, which hooks to this yellow wire. It goes to the power switch. I'm not going to reposition you. It goes to the power switch. The other wire for the power switch comes back and hooks to the transformer. The neutral lead hooks directly to the transformer. It'll make sense on the schematic. One moment. One moment. Okay, guys. This is the AC line input to the transformer, to this rig. You'll notice that it does not have a grounded plug, nor is it polarized. So which line is hot and which is neutral? Neither. Either or. Depends on which way you plug it in. And that's not good. That is not good. How could it kill you? It's not very likely. It's not very likely. But if you've got it plugged in such that this line is hot, it's always connected to the circuit breaker, which is always connected to the transformer. The transformer's always hot. If anything goes wrong in that, even when it's turned off, transformer's hot. If anything should go wrong in that transformer, and it happens a lot, you might be surprised. If one of those windings shorts to the core, and the core's bolted to the chassis becomes hot, you've got your hands all over that thing, man, and you touch something that's grounded, boom, you're dead. So what did I do to fix it? I'm going to pause your hand. I did that. This is the way it has to be done. Where you going, Scout? Don't go. This is the way it has to be done. Period. End of story. The hot. Now, first you have a polarized grounded plug. The hot must go to the fuse first, not the power switch. It must go to the fuse. Then you can go to the power switch. And now then, with it configured as such, when the power switch is turned off, the transformer's not hot. Only the fuse would be hot. Through the fuse into one terminal of that power switch. And that's a hell of a lot better than having that transformer always hot at all times, even when it's turned off. That's crazy. Well, guys, I better wrap this up. What next? Well, I will say this. The receiver hasn't come to life yet, but the audio output stage has. When I touch pin 2 of that tube, which is the grid of the preamp, I get a nice healthy blast of audio. And so, where do I go now? It's time to troubleshoot this thing. and get it working. Now what? What do I plan to do? First, check all the voltages as per the manual. If I have anything grievously wrong, that should uncover it. Next, I will check for assuming if all the voltages are okay, I want to check for the operation of the local oscillator and the heterodyne oscillator. Those two oscillators have to be running for this thing to receive. Once I verify that those are, and how would you check those? Well, if you're so fortunate, God, I'm whistling again. If you're so fortunate to have a spectrum analyzer, that'd be great. Otherwise, a good scope or an external receiver. Once I get it working, then I'm going to test and get working the transmitter, then align it, and then I'll be done. So I'll be back. I want to do a video, a real short one, about a note about using a dim bulb. Look at that shorted plug. You dare me? We'll do that next time. And then I want to do a video about troubleshooting the audio output tube. Might be interesting for a few of you. I hope you're well. I'll talk to you later, guys. Bye now.